Hey, Math Journey! What if I told you there's a sneaky little polynomial problem that reveals its secrets with just a few clever moves? Today, we're tackling a challenging question that looks complex at first glance but can actually be cracked step by step. So here's the setup. We have a polynomial function, which we'll call f of x. And it's given that it satisfies the following equation for all real values of x. X plus 7 times f of 2 times x equals 8 times x times f of x plus 1. We also know that f of 1 equals 1. Problem needs us to find the value of f of minus 1. Now, before we dive into solving this, take a moment to think about it. What jumps out at you? Can you spot any connections or familiar ideas? Even complex problems often have a simple starting point. Give yourself a few seconds to explore the possibilities, and then we'll solve it together. Well, if you focus on the problem, there is a tricky part. The degree of this polynomial nowhere specifies. We need to somehow find it. Let's assume f of x is a polynomial of degree n. So, we can write it in its general form as f of x equals a 0, plus a 1 times x, plus a 2 times x squared, and so on, up to a n times x raised to the power of n, where a n is the coefficient of the highest power of x. To solve this, our first step will be to use the given equation to identify this highest degree term, which will help us determine the polynomial's degree. Now, let's take a look at our main equation. X plus 7 times f of 2 times x equals 8 times x times f of x plus 1. We'll start by looking at the highest powers of x on each side to make our calculations easier. On the left side, we have x plus 7 times f of 2 times x. To identify the highest power of x, let's substitute 2 times x in place of x for the highest degree term in f of x. So, for f of 2 times x, we get the term an times 2 times x raised to the power of n, which equals 2 raised to the power of n times an times x raised to the power of n. Then, by multiplying by x, we end up with 2 raised to the power of n times an times x raised to the power of n plus 1. On the right side, we have 8 times x times f of x plus 1. Substituting x plus 1 in place of x for the highest degree term in f of x, the highest power term on this side becomes 8 times an times x raised to the power of n plus 1. Equating the two sides, we will get 2 raised to the power of n equals 8. Solving this, we find that n equals 3. So, f of x is a cubic polynomial. Since we've established that f of x is a cubic polynomial, let's write it more specifically. F of x equals a 0, plus a 1 times x, plus a 2 times x squared, plus a 3 times x cubed. Now we'll use the information from the problem to solve for each coefficient. Let's plug in some values of x to simplify our work. Starting with x equals 0. 0 plus 7 times f of 0 equals 8 times 0 times f of 1, which gives us f of 0 equals 0. Next, let's try x equals minus 7. Minus 7 plus 7 times f of minus 14 equals 8 times minus 7 times f of minus 6, which gives us f of minus 6 equals 0. Finally, if we try x equals minus 1, we find that f of minus 2 equals 0. We now have 3 roots. X equals 0, x equals minus 6, and x equals minus 2. This means we can express f of x in a factored form. Using these roots, we can write f of x as f of x equals a 0 times x plus 6 times x plus 2. Since we know that f of 1 equals 1, let's substitute x equals 1 to solve for a 0. F of 1 equals a 0 times 1 plus 6 times 1 plus 2 equals 1. Simplifying this, we find that a 0 equals 1 over 21. Finally, to find f of minus 1, we'll substitute x equals minus 1. F of minus 1 equals 1 over 21 times minus 1 times minus 1 plus 6 times minus 1 plus 2, which simplifies to f of minus 1 equals minus 5 over 21. And there's our answer. The value of f of minus 1 is minus 5 over 21. If you enjoyed this challenge, don't forget to hit that like button and subscribe to Math Journey for more fun math adventures. Now that you've seen the answer, how did you do? Were you able to crack it? Let me know in the comments. And share this video with a friend who loves brain teasers to see if they can solve it without peeking at the solution.